Hello everyone, welcome to video lecture series on microcontrollers and applications. We are at lecture number 8. In this lecture, we are discuss about conditional control transfer instructions of the 8051 microcontroller. In last class, we discussed logical instructions, where we discussed the syntax of logical instructions, working of logical instructions, examples of logical instructions, and applications of logical instructions. Coming to learning outcomes of this lecture, after completion of the lecture, you may achieve three learning outcomes. The first one is identify and use conditional branching instructions in 8051 assembly language. Understand how flags influence program control flow while executing instructions. Write decision-making routines using flags, comparisons, and counters. Control transfer instructions. Control transfer instructions are also called as branch instructions. Branch instructions transfers execution control to the specified address in the instruction. To be specified address in the instruction. Branch instructions are classified into two types. They are conditional branch instructions. Another one is unconditional branch instructions. Conditional branch instructions transfer the execution control to address specified in the instruction only if the specified condition is met. That means satisfied. Otherwise, the program normally proceed with next instruction. Suppose here one example is available. So XX is the destination instruction address when this condition is met. Suppose for example, JC stands for jump if carry. Jump if carry. That means it checks carry is equal to 1. The condition is here, carry is equal to 1. Let us consider I performed an operation ADD A comma P. After this condition, let us assume carry flag is equal to 1. I am checking the carry flag is equal to 1 within this instruction. So that means after the instruction carry is equal to 1, I am also checking carry flag. So that means the condition is met. Whenever the condition is met, the instruction branches to address specified within the instruction. Okay. This type of instructions are called as conditional control transfer instructions. Here the not only the carry, so any other condition is also there. Unconditional branch instructions. These instructions transfer execution control to address specified in the instruction without any condition. Okay, without any condition. Example is ljump. So once this ljump instruction is executed, it will branches to this address specified within the instruction. It won't execute the next instruction. Okay, but in this case, there is a possibility. If the condition is not met, suppose for example here, carry is equal to 0 after the addition, then you are used to JC instruction. This JC instruction checks for carry is equal to 1, but after this operation, this is equal to 0. That means the condition is not met. So whenever the condition is not met, so it is immediately proceeded with next instruction. Okay, it will execute the next instruction. This is the definitions of both conditional branch and unconditional branch instructions. Next, we will see conditional control transfer instructions. Under conditional control transfer instruction, there are several instructions are supported by 8051 microcontroller. First one is jump if carry. So let us see once this instruction will be executed once. So let us consider here we are having instruction 1, 2, 3, and so on. Then we have ADD A comma B. Now let us see two cases of this instruction. Carry is equal to 1 after this operation. Carry is equal to 0 after this operation. So let us consider after addition I am used this JC instruction. JC next. Okay. The next I am specified here next. So that means whenever this instruction condition is satisfied, it will transfer the execution to this labeled location. That means it will goes to here. That means it execute the instruction from again from instruction 1 onwards. Okay. So, but here we'll see. Let first case we'll consider. So carry is equal to 1. This instruction is also checking condition carry flag is equal to 1. So in this case, carry is equal to 1. So that means in the first case, the execution control is transferred to address specified within the instruction. That is next location. So that means it will execute the instruction from instruction 1 onwards. Now after this addition, the carry is equal to 0. The carry is equal to 0, but the instruction is checking carry is equal to 1. So that means here the condition is not satisfied. Not satisfied. Once the condition is not satisfied, the instruction may not jump to this location. Instead, it will pass the instruction to next immediate instruction. So let us consider next immediate instruction is sixth instruction. Okay, so it will pass the execution control to sixth instruction. So this is the actual operation of conditional control transfer instruction. Okay, so similarly we can also discuss for remaining conditional control transfer instructions. All instructions are working same except only the condition. Only the condition will be changed. Remaining operation is as it is for all the conditional control transfer instructions. Okay, then next one is the condition is carry is equal to 0, jump if no carry. JNC stands for jump if no carry. Then jump if bit, jump if no bit. Here we will see jump if bit is nothing but let us consider I am having jump if bit. The syntax is jump if bit. Any bit you need to specify here. Suppose for example bit comma relative address. Here what is relative address we will discuss later, but just we need to see what is this bit. This bit may be any bit of the bit addressable location. Bit addressable location within the RAM. Bit addressable location within the RAM. That means it can be have the bit addresses ranging from 00 to 7FH, or this bit may be any bit addressable any bit addressable register bit. Okay, so let us consider the example for bit addressable register is let us consider port 0. So port 0 is having 8 bits like this. 8 bits are there. So this is port 0.0, this is port 0.1, 2, and so on, port 0.7. That means I can use here example as jump if bit port 0.0 comma relative address, or in this case I can write example as jump if bit 00h comma relative address. So that means this bit may be any one bit within this bit addressable location, or any bit like this as port 0 as described here. So this is about J and B. The operation is same. If the bit is equal to 1 in this case, if this bit port 0.0 is equal to 1 in this case, the condition is satisfied. Otherwise, next instruction will be executed. So then JBC, jump if bit, okay, sorry. Jump if no bit is also available. In this case, bit is 0. So the condition is here. In this case, bit is 0. Next case is jump if bit and clear carry. If bit is 1, it jumps to location address specified within the instruction, relatively specified in the instruction, and the bit is automatically cleared here. In previous case, if it is bit is 1, it jumps, that's it. But in this case, while jumping, it will clear that corresponding bit. Suppose, for example, let us see now. Jump if bit carry clear. In this case, port 0.0, comma, relative address. Let us assume here 1 is available before execution. Then it checks the port 0.0 is equal to 1. Yes, this is 1 only. When this goes to relatively specified within the instruction, execution control is transferred to this address specified within the instruction and clears this bit. Okay, so this is the operation of jump if bit and clear the bit. Jump if bit and clear the bit. Next, we'll discuss jump if 0. The syntax for this instruction is JZ relative address. JZ relative address. JZ relative address. We'll see one simple example. Jump if relative address. Here, JZ jump if accumulator equal to 0. A is equal to 0. It checks condition is A is equal to 0. A means here accumulator. So accumulator 8 bits is equal to 0. Then only it jumps to address location, specified address in the instruction, relative address. This is the syntax. And similarly, jump if no 0. So in this case, A is not equal to 00H. Then only it will jump to new location. Otherwise, it proceeded with next instruction. Next, CJNE register has data. CJNE A comma byte. CJNE, sorry, next DJNZ count comma label. So here we will discuss these three instructions briefly in next slides. And one more important thing here we need to note down. All conditional jumps are short jumps. This is the one of the important thing we need to remember here. All conditional jumps are short jumps only. Let us see what is meant by short jump. While discussing this, all these instructions, I mentioned that there is a relative address. There is a relative address. Normally, our programs are stored in a program memory. With the address is ranging from 00H to FFH, 4FH. So this is my program memory. Always my programs are starts with this location, most of the cases. And here, let us consider now my program, these instructions, the conditional jump instruction is available at this instant. So for example, so let us consider it is 2000 H. So let us consider I executed this JZ instruction. Okay, at this location, JZ instruction is available. JZ some relative address. Okay, so relative means here JZ relative means it is a signed 8-bit address. A relative address is nothing but signed 8-bit address, which is relative to PC. Hence, the target address is always minus 128 bytes to plus 128 bytes relative to the PC. Actually, here you need to use only 8-bit address, 8-bit relative address. Here we are representing this is a relative address, but this is a 8-bit address. That 8-bit address is nothing but which is ranging from 00H to FFH. Let us consider if I use any number in between 00H to FFH, it is a signed number. Signed number means it is having positive values as well as negative values. That means if I use FE means minus 2. So that means minus 2 locations from this address. Okay. So while executing this instruction, let us consider it is a 2-byte instruction. Then the PC is having 0 to H. While executing this JZ instruction, PC is having this instruction. The address 2002 address. So whenever I am placed JZ FE 0 FEH is nothing but if the condition is satisfied, okay, it will jump to this address. Means that this address is not available directly in 8051, but it is related to PC. That means the PC value will be added to this address specified within the instruction. What is the value here? This is minus 2. FE is nothing but minus 2. 2002 minus 2 is nothing but 2000H. That means after execution of this instruction, it will execute the same instruction again. So that means why it execute the same instruction, we are provided minus 2 here. And similarly, this is called as a backward jump. Okay, this backward jump is possible up to minus 128 locations from the current program counter value. From the current program counter value means this is the current program counter value. From this onwards, you can jump up to minus 128 locations in backward direction. Similarly, you can also jump up to plus 127 bytes from the current look program counter value. Suppose, for example, if I executed this instruction, jump F0 06H means this 06 will be added to this 2002 current program counter value. That means the new updated PC value becomes G2008H. So that means it jumps to a forward location 2008. From this location onwards, it will execute the instruction. So this is the operation of short jump in 8051 microcontroller. Now let us discuss a jump if carry clearly. JC stands for jump if carry. This will check condition is carry is equal to 1. Syntax is JC label. Here label refers to a symbolic name assigned to a memory location. A symbolic name assigned to a memory location. The operation of this instruction is this instruction checks carry is equal to 1. The CPU start, fetch and execute instruction from the address of the label. Address of the label is nothing but whatever the address you are relatively specified. From that address, it will execute the instruction. If the condition is not met, that means condition carry flag is equal to 0. It will not jump, but will execute the instruction below the JC. Okay, that means whatever the instruction immediately after JC instruction will be executed now. All conditional jumps are short jumps only. In case of conditional jumps, relative address is used as a label, and a relative address is a 8-bit signed 8-bit address which is relative to PC. Hence, the target is always in between minus 128 bytes to plus 127 bytes relative to PC. Let us see one example here. Move A, comma, hash 0 FFH, add A, comma, hash 0 1H. Now I executed here JC down. If you consider these two here, the carry is equal to 1 in this case. Now let us see, this is instruction is also checking for carry is equal to 1. So that means here the condition is met. Once the condition is met, this instruction won't execute this move port 1 comma hash 00H. Instead, it will jump to this down location, labeled location, and it will execute move port 1 comma hash FFH. Okay, then we need to discuss DJNZ, decrement jump if not 0. The syntax is decrement JNZ counter comma label. Here also label is relative address only. That means signed 8-bit number, relative address only, relative to PC, and the the operation is the counter is decremented if it is not 0. It jumps to target address referred to by label. That means this instruction first decrement the counter by 1 and then checks for the counter is not equal to 0. If it is not equal to 0, the counter is not equal to 0, then the condition is satisfied and it will jumps to label location. It will perform two operations actually. Decrement the counter. So first it will perform C is equal to C minus 1. Then it checks for this condition. If the condition is met, it jumps to relative address. Otherwise, it will execute the next instruction immediately after DJNZ instruction. Then, prior to start of the loop, actually this instruction is used to repeat a set of instructions n number of times. The application of the DJNZ instruction is a set of instructions. Suppose, for example, first instruction, second, third, fourth instructions are there. I need to repeat these 4 instructions 20 number of times. 20 number of times. Then I need to write DJNZ instruction with R0 comma XX. This XX will goes to here. I need to repeat from here. So that's why this destination address need to be placed here. Label should need to be placed with colon. And I need to repeat this 20 number of times. That means before starting up, prior to start of the loop, the register, whatever the counter register we are used, that should be loaded with move R1 comma hash 20. Here I am consider this is a decimal number. That's why I am ignored here H. So this is a decimal 20. So now this loop, these 4 instructions are executed 20 number of times. Why? Because in first case, it will decremented by 1. That means 19. This 19 is not equal to 0. So that means it will jump to here. Then second case 18. 18 is not equal to 0 and so on up to 0. 0 not 0 equal to 0. 0 jump if not equal to 0. We are checking for not equal to 0, but finally after 20 iterations, this counter value will become 0. So in this case, the condition is failed. Once condition is failed, this instruction will execute the next instruction after this DJNZ instruction. Then counter can be R0 to R7, any bank register or any RAM location. If you want to repeat an action uh, more times than 256, we can use loop inside a loop, which is called a nested loop. Suppose in some cases we need to repeat these two instructions further. Okay. Suppose for example, the here I used a counter. This counter is a 8-bit counter. So the maximum value I can place is here 255 only. That means this loop can be executed how many number of times? 256 times. But I need to repeat these two instructions further. So that means I can use one more loop. So that means I can utilize one more counter register R1 and load with some other value 20 hits. In this case, 255 times into 20 times. So that many times this loop will be executed. This type of loops are called as nested loops. Okay. So when the if the counter register is not sufficient, you can go with nested loops to increase the number of iterations, number of loop iterations. This is the advantage of this application or advantage of this loop instruction. That loop instruction is DJNZ instruction. We use multiple registers to hold the count. Let us see example here. Let us consider I need to write a program to perform add the value 3 to accumulator 10 times. So in this case, what we need to do? First, accumulator should be cleared to 0. Then move R2 comma hash 10. So I'm using here counter as R2 register. The count value is 10. Then I added A with 03. I need to add 03 10 times to accumulator. So that means I added here. Then I used DJNZ for looping R2 again. So here what happens in first step, here it is 0, it is 3. The answer is 3 only. Here 3 will be there in accumulator. And it is checking. First it will decrement by R2 is decremented. That means it is 9. So the 9 is not equal to 0. That means it jumps to here. Again 3 plus this 3 will be added and this becomes 8. Again 3 and so on. Once this is equal to 0, this is added 10 times. Now we will get 30 is in decimal in accumulator and now R2 becomes 0. Once R2 becomes 0, this condition is failed. Next instruction will be executed here. So that is move R5 comma A. We have stored the final result 13 decimal into R5 register. Okay. Then CJNE instruction. Compare jump if not equal. The syntax is CJNE A comma direct comma relative address. CJNE A comma hash data comma relative address. CJNE R comma RN comma hash data comma relative address. CJNE at the rate RI comma hash data relative address. So these are the four different mnemonics supported by CJNE instruction. But here direct means any address. Here any immediate data. Here also any immediate data. Here also any immediate data. Here the destination is accumulator. Here any RN register, bank register. Here any memory location, but it is indirectly specified. Operation of this instruction is the CJNE instruction compares two operands, the source operand and let us consider we will take this example CJNE A comma hash 12H comma relative address. If you see not equal, it is checking for not equal. A is not equal to hash 12H means A value may not be 12H. Then only the condition is satisfied. So when the condition is satisfied, it jumps to the address location. Otherwise, it will simply execute the next instruction. The operand themselves remain unchanged. The operands may not be changed. And it changes the carry flag to indicate the destination operand is larger or smaller. Based on this, we can identify A is larger than the source operand or less than the source operand or equal to source operand. The example is CJNE A comma hash 12 already we seen. The summary is in this session we discussed the following key points: control transfer instructions, syntax of conditional control transfer instructions, working of conditional control transfer instructions, examples of conditional control transfer instructions. In next class, we will explore how 8051 uses unconditional instructions like sjump, ljump, ajumps to alter the program flow without any conditions. Today, quote is in this program in programming as in life, the power of decision lies knowing when to take the jump. Conditional instructions are how microcontroller make choices that matter. Thank you.